Okay, so the next step for us to do in looking at and sort of pursuing our data analysis is to make sure that is to try to get us an overview of all of the graduation rates in New York State. And so we can see here that we've got graduate percent, the percentage of students that have graduated in that year, and so we want to be able to do something on this. So we've already used our text facet a few times to kind of narrow, get a quick overview on our data and also narrow down the data that we're looking at, and generating a new file to do that in. So we've been using a text facet. What we want to do for this is generate a numeric facet. And a numeric facet is really a histogram, which is great because a histogram is the primary way that we reveal the so-called shape of the data, right? It's not the only way, but it is one of the primary ways when we're dealing with multiple entry type data. So we want to do a numeric facet on it. Well, that's great. The problem is that this percentage sign is screwing up our ability to do a numeric facet because it is causing the program to interpret this percentage as a string. So what we're going to do is, and there's always lots of different ways to sort of do data manipulation. In this case, I could open this in Excel and sort of strip out the percentage sign that way, because Excel would probably convert that to an actual percent. I'm going to take a different approach here because I don't feel like opening up Excel right now. And so instead I'm going to say split into several columns. Now this is really just a trick because what I want to do is I really just want to get rid of that percent sign. So I'm going to say split this column by the percentage sign, and what I should end up with is two columns, one of which will likely be empty, and then the other which will just contain my number. And so you can see that it says guess cell type, and it's removed this column, right? These are all just options that I can choose. And indeed, when I do that, I see that now my graduate percent is actually a number. And again, how can we tell this? Because it's green. So you see a lot of consistencies, not necessarily with the specific color, but you see a lot of consistencies in the way that we use that visual cueing is used in these programs to do things like indicate data types. So now I'm just going to go ahead and get rid of this extra column because I don't want it anymore. And so now I can go to my graduate percent and say, okay, let's do a text facet on this. So when I look at this, and you should all at this point have looked at our normal curve, and what we see here is that, okay, so it looks like, pretty much there's something that resembles our bell curve. It's got a little bit of skew, right? Because there are some, there's a limit. I'm already intrigued by the fact that the top number here appears to be 101. And it looks like there's some non-numeric, so there's some sort of blanks that we probably don't, missing numbers that we don't want to include. And we have some, way down at the bottom as well. And so the thing that we need to do before we can decide what type of analysis is appropriate, we need to understand if this data is quote-unquote normal or not. In other words, is it normally distributed, or is there a lot of skew to the data set? This is important to determine because whether it's a normal distribution or a skewed distribution will dictate which measures we can use to assess the relative expectedness of a particular data point. So if it's normally distributed, then we can use the mean and the standard deviation, right? The numerical, the arithmetic mean, right? Add them all up and divide. And the standard deviation, which we'll look at in class, we can use that to describe the curve, right? If it's not normally distributed, then we need to use the median and quartiles to get a sense of how expected or unusual a particular value might be. So again, we're thinking 75%, is that really a little? Is that actually fine? How dramatic is this number? Or likewise, if somebody says, we have a graduation rate of 90%, how unusual is that? So we've got something here, and as we noted, right, there is a little bit of a tail, but it's broadly normally distributed. Now, the trick is, how can you tell, what are the criteria that are used for measuring this? Well, or for assessing, I don't know, maybe that's normal, but maybe some people would say it's not. The way that we can do this is by actually doing the mean and standard deviation calculations and using them to kind of as a sort of rough approximation for the distribution of the percent of values. So how does this work? We're going to start by normal distribution. Right? There are any number of graphics on the internet that include these values. This is actually a pretty good one that I like. We also have here's a more brightly colored one. And what I like about this, so this is going to show you, this actually has a bunch of additional information, but one of the most important elements and one of the reasons why we care about the normal curve at all is because we can see that the majority, over 68% of values in a data set that follows a normal distribution, about 68% of values fall within one standard deviation of the arithmetic mean. So what we can do is we can say, okay, well, we're looking at our data and it looks like it might be kind of normally distributed, but maybe not. And we can do these calculations and say, well, look, because this 68% corresponds to the normal distribution, these percentages correspond to the normal distribution, if the distribution of the values in my data set match these values, then I'm pretty certain that my data set is normally distributed. Does that make sense? It's going to be kind of a mirrored, we're kind of mirroring the logic. So in order to do that, I'm going to take my data set here. I'm going to, I guess I'll re-export it. Well, I'll just go ahead and open it up in Microsoft Excel. Now, actually, you can use any spreadsheet program for this. I'll use Excel in this case. I often use OpenOffice. One question, of course, whether you have access to the particular software. OpenRefine is open source and free, which is another lovely thing about it. And so I'm going to go ahead and take this. I'm going to open my file, and I guess we'll actually see a few different ways to get at this. And so here we go. Now this is interesting because it says all readable documents. So let's do, it may not understand tab separated value. Okay, so it's asking characters such as commas or tabs. The file extension TSV is actually very new. I've not really seen people use that until the last 12 months or so. And so now I'm going to go ahead and just say, please import my data. And we see that graduate percent is still, let's go to format cells. Let's see if we can't. Let's see if I do it as a percentage. What happens? Interesting. Okay, so I'm going to say format cells, come over here and say number. And I'm going to use 0 decimal places. Oops, right, because now it's interpreting it as a percent. And because of that, we actually do need it to be a percentage, right? You can see that it's either coming up as 0 or 1, but in our detail bar up here, you see that it's 0.86, etc. So I'm going to do one more formatting here. And I could also have just re-exported, which perhaps I should have done. I can just re-export the value from my data set from Google Refine and use that instead of futzing around with this. So I'm actually going to use 2, and we have 0.47. That's fine. Because what I want to do is I want to calculate the mean and the standard deviation. And fortunately for us, we will be going over exactly how these things are generated. But not surprisingly, there are formulas built into Excel, and again, pretty much every other spreadsheet program, Google Spreadsheets does this as well, that, let me say, so the way that we signal a formula in Excel is by starting with an equals sign. And average is the name of the function that calculates the average, or the arithmetic mean more specifically. Now, how you select the cells that should have the average generated is up to you. There are some people who like to do Apple D. I like to just use the arrow keys to go to a cell and then sometimes scroll up and highlight. So if you highlight the top and bottom values, this is not working very well. If you highlight the top and bottom value, we'll select all the ones in between, and I can now see that the average percentage is 81%. So this is interesting because 81% is not all that different from 75, but maybe it's really different from 70, right? We need to understand what we have now is we have a center point that we can refer to, but we need to understand the standard deviation, which is basically a way of describing how spread out that normal curve is. So even though when we look at pictures of the normal curve, you know, sort of the classic normal curve, it always has this shape. The important thing about a normal curve is the symmetry around the average, right? That there's a center point and you could mirror image it. It could be taller, it could be flatter. As long as it has that symmetry, it is still a normal distribution. So if you see something where it's, you know, a curve more like this, right? It's a lower curve. It's still normally distributed if it has symmetry around that central mean. So you know, it looks pretty normal, but I'm not exact, you know, I wouldn't stake my reputation on it. So the next thing that I'm going to do is calculate the standard deviation. And once again, we are lucky because Excel has a function for this. And we're going to use stdev standard deviation.s. S stands for sample in this case. It is a slightly different formula than for a so-called population. We could argue that this is actually a population sample, or this is actually a population because it is a measurement of all of the schools in New York State. So the distinction being that the population is all of the possible data points have been collected, whereas a sample would obviously be just that, would be choosing a representative subset of all the possible ones. So I'm going to use sample for now, and I might change my mind about that. So once again, what I want to do is just select all of my data points and say, okay, what's a standard deviation here? And so now I start to see something interesting, right? So if we look back at our chart, we'll recall, or we look back at our image here, right? We'll recall that one standard deviation, if you're within one standard deviation of the mean, you are in the broad chunk, right? You're over 2/3 of our values are going to be within one standard deviation above and below the mean. So even from this, we can say, okay, well, if this is a normal distribution, you know, even a value of 70 is well within normal range because the mean is 81%, the standard deviation is 13%, which means that we would only probably think of it as unusual, right? If it was, you know, if a particular value was below, if a particular graduation rate was less than 68% or above 94%, right? So the mean, you know, it can be normally distributed anywhere along the possible range of values. It doesn't have to be quote unquote in the middle. So the next thing that we're going to do is we're going to look at how we would apply this to the actual proportions in our data set. So really quickly, I just want to point out that if I were to say, look at all of the values that are one standard deviation from my mean. So this is a nice little selector tool I can use here. And so this is now, it's showing me the number of matching rows. So I'm going to check and say, okay, if I start at 81 and go down to 68, right, which are the values, it gives me 197 matching rows out of 688 total. Actually, I want to go within one standard deviation of the mean, so I'm also going to go up to 94. And what I'm looking for here is if I have 512 matching rows out of 688 total, then here we are. So I'm just going to do some quick math. Equals, forgot the number, 512 divided by 688. Okay, 74%. Not dead on, but pretty close. So what we're going to do in the next section is just do the comparison on the remainder segments of the data and then make an assessment about whether we think that this is a normally distributed data set or a skewed data set. And from there we can start to think about our our account of whether it is normal or not and whether our value of 75% or 70% is really all that remarkable.